Okay, welcome back. This time I have a problem from the Indian National Math Olympiad 2013. A, B, C, D are positive integers such that A is bigger than or equal to B bigger than or equal to C, and C bigger than or equal to D. We must prove that this equation has no integer solution. So, in other words, this quartic polynomial has no integer root. Okay, so in this video I will show two solutions. I start from the first one. The strategy to solve this is using contradiction. So we assume first that the equation has an integer solution. Let x0 be an integer solution. So we have this equation in terms of x0. And then the strategy is we want to find contradiction. So we will collect some facts based on this assumption that it has integer solution. So the first one is, since the constant d must be at least 1, so we cannot have x to be 0, because if x is 0, then we have that d must be 0. So that is contradiction, because d must be positive integer. So this is the first fact, and then we can put d on the right hand side and we can factor out the x0 on the left hand side. So we can see that x0 x0 divides the constant d, because d is a multiple of x0. So x0 divides d, that is the second fact. And then now let us check whether it is possible for the solution to be negative integer. If it is negative, then it is less than or equal to -1, because it is integer. Then x0 power of 4 also at least 1. But x0 power of 4, we can write it another way. That is, this is x0 power of 4 is equal to all of these negative terms put on the right hand side of the equation. So we have this x0 power of 4 equals this, and this will be non-positive because x0 is negative. So x0 power of 3 is negative. But although x0 squared is positive, notice that the coefficient of x0 cubed is a, and a is more dominant than b. So ax0 cubed plus bx0 squared will never be positive integer. This will be non-positive. And also the same for this one. x0 is negative, and although d is positive, but x0 has coefficient c multiplied by c. So this is dominant. The negative wins. So each of these two terms cannot be positive number. So they must be non-positive, less than or equal to 0. And this is a contradiction, because x0 power 4 must be bigger than or equal to 1. But this we found that it is less than or equal to 0 too. So we cannot have x to be negative. So the solution must be at least 1. So we have the solution is at least 1, and the solution must divide d. This means that if x0 divides d, it must be less than or equal to d. So we have this bound for the solution, and also d is less than or equal to a. So we have this bound too for the solution. x0 is less than or equal to a. This bound we have for the solution, and then we must also have this x0 power of 4 is equal to x0 times x0 cubed. We can write it this way. So this one x0 is less than or equal to a. So we have all of this. x0 power of 4 is less than or equal to a times x0 cubed. But ax0 cubed is less than itself plus these positive terms, right? And so x0 power of 4 is less than or equal to ax0 cube, but ax0 cube is less than all of this. So we found that x0 power of 4 is less than all of this. And this is a contradiction because all these terms involving a, b, c, d are must be equal to x0 power of 4 based on this equation, this quartic polynomial equation. So we get a contradiction. So for any possible integer solution, you always get a contradiction. So this is our first solution. And now let us move on to the second solution. For this solution, we will also use a contradiction. We assume that it has an integer solution, but it is slightly different here. And we also use the previous result that we already know that x0 cannot be equal to 0. It must be non-zero. Okay, and then first notice that x0 power of 4, I can write it this way. x0 power of 4 equals to all of this. x0 squared times ax0 plus b plus cx0 plus d. Right, I just move all the terms, a, b, c, d terms to the right hand side. And these two terms are important, ax0 plus b and cx0 plus d. Now, if the solution is negative, we will check here whether it is possible for the solution to be negative. Then ax0 must be less than or equal to minus a, because x0 itself is less than or equal to minus 1. And then from here, if I add b to both sides of this inequality, we get that ax0 plus b less than or equal to b minus a. And a is bigger than or equal to b, so b minus a must be less than or equal to 0. So we get here that this term ax plus b must be non-positive. It is at most 0. And also similarly, we can use the same way here to get to cx0 plus d less than or equal to d minus c and less than or equal to 0. So this term too, cx0 plus d, is non-positive, at most 0. But here we get a contradiction because that x0 power of 4 must be at least 1, right? And then x0 power of 4 is equal to all of this. And although x0 squared is positive, but this ax0 plus b is non-positive and cx0 plus d is non-positive. So all of this will be non-positive. We get a contradiction, so this proves that the solution x0 cannot be negative. Now let us check the other case. What if the solution is positive? If x0 is bigger than or equal to 1, then it is easy to check that both ax0 plus b and cx0 plus d is bigger than 1. That is obvious, because ab is at least 1 and cd is at least 1, right? And of course ax0 plus b must be the dominant one. It is bigger than or equal to cx0 plus d. And then now notice that x0 squared, it is obvious, it divides x0 power of 4. And this is crucial because x0 squared divides all of this. This is just another way to write the x0 power of 4, right? And notice here we have another x0 squared in the first term right here, x0 squared times ax0 plus b, but we don't have x0 squared here. But since it must divide all of this, so x0 squared must divide cx0 plus d. So if x0 squared divides cx0 plus d, it means that x0 squared is at most cx0 plus d, and cx0 plus d is at most ax0 plus b. So all of these, each two terms is bigger than or equal to x0 squared. Now this we get a contradiction because we have x0 squared times ax0 plus b is at least x0 power of 4. But then we have this term, positive term, So we have this one, this first term, that is at least x0 power of 4 plus a positive term, which means that it will be bigger than the left hand side, the x0 power of 4. You see here it is bigger than x0 power of 4, and this is a contradiction. So for all possible integer solutions, we get that we always get a contradiction for this quartic polynomial. So we have solved this Indian National Math Olympiad problem. Okay, thanks for watching and see you on my next videos.